Okay, so once again, good morning, and our topic for today is about network, no? So a network protocol is an established set of rules that determine how data is transmitted between different devices. So in the same network, essentially, it allows connected devices to communicate with each other regardless of any differences in their internal processes, structure, or design. So network protocols are the reasons you can easily communicate with people all over the world and thus play a critical role in modern digital communications. Similar to the way that speaking the same language simplifies communication between two people, network protocols make it possible for devices to interact with each other because of predetermined rules built into devices, software, and hardware. So neither local area networking nor wide area networking could function the way they do today without the use of network protocols. So the network protocols take large-scale processes and break them down into small, specific tasks or functions. This occurs at every level of the network, and each functions must cooperate at each level to complete the larger task at hand. So the term protocol suit refers to a set of smaller network protocols working in a conjunction with each other. So network protocols are typically created according to industry standard by various networking or information technology operations. So while network protocols model generally work in a similar ways, each protocol is unique and operates in the specific way detailed by organizations that created it. So, of course, network protocols aren't only relevant to certified network specialists or IT professionals because billions of people use network protocols daily whether they know it or not. So, every time you use the internet, you leverage network protocol. So, though you may not know how network protocols work or how frequently you encounter them, they are necessary for using the internet or digital communication in any capacity. So, there are thousands of different network protocols, but they all perform one of the three primary actions: for communications, network management, and of course, for security. Each type is necessary to use network devices swiftly and safely, and they work together to facilitate that usage. Okay, so for us to discuss about the networking protocols, and at the same time, the IPv4, IPv6, domains and subdomains, no? URL, DNS server, web servers, email servers, and FTP servers ports. Let us all welcome Sir Josh. Take it away, sir.
Hello, good morning everyone. So, for our benefit, no, I prepared the video. So, please bear with me na lang po kasi talagang ano lang, bagong bunot lang. So, any questions will be catered after the video na lang po. Thank you and God bless.
Everyone, so I'm Sir Josh and I'll be your porter for today. So we will be tackling about networking protocols. So just an overview about this before continuing to IPv4 and IPv6. So all throughout this lesson, we will be learning about network protocols, type of network protocols, and then we will dive into internet protocol, routing protocols, IP addressing, which is IPv4 versus IPv6, types of servers, URLs, domain name system, domain and subdomains, and ports. Okay. So networking protocol. So when we say protocol, it is a standard set of rules in which it governs how data or how we understood data throughout client and server. Okay. So same with our communication, like our language, it is something that we have a common ground on for us to understand each other. So same with networking protocols. So types of networking protocol. So we have TCP, so Transmission Control Protocol. It is a popular communication protocol which is used for communicating over the network. So it divides any message into series of packets that are sent from source to destination, and there it gets reassembled at the destination. So TCP involves or revolves in how data is fragmented into packets which are sent from source to destination, while Internet Protocol is designed explicitly as an addressing protocol. So it is working hand in hand with TCP. So the IP addresses in packets help in routing them throughout or through different nodes in a network until it reaches the destination system. So as again, TCP/IP is the most popular protocol connecting the networks we have today. So contrary to TCP is more on fragmentation, dividing the data into packets, while Internet Protocol is more on the addressing and routing of that data. Okay, so some other protocols include Post Office Protocol, which is used for receiving incoming emails. We also have User Data Protocol, or UDP, a substitute communication protocol to TCP, so implemented primarily for creating loss tolerating and low latency linking between different applications. So this is also a counterpart naman ng TCP. So they are somewhat related when it comes to communication, but UDP focuses on creating loss tolerating or low latency links between different applications. So SMTP. So SMTP naman is a protocol which is designed to send and distribute outgoing emails. So prior to Post Office Protocol, so Post Office Protocol is more on receiving, while SMTP is more on sending. We also have File Transfer Protocol. So an FTP allows users to transfer files from one machine to another. Types of files may include program files, multimedia files, text files, and documents, and etc., or any soft copy files that we have in our file system to another file system. So we use FTP in that cases. We also have what we call the hypertext transfer protocol. So HTTP is the one mostly used in terms of viewing websites. Okay, it's more on transferring hypertext markup languages or web pages from one client to another. Okay, so that is hypertext transfer protocol. So HTTPS is another counterpart or an upgraded version wherein it's a standard protocol to secure or a secure HTTP protocol for communication among two computers, which uses a browser and other fetching data from the web server. Okay, so this is just a short review or brief introduction in networking protocols. So for us to dug deeper or get to acquaintances with what we are going to learn throughout this path or learning path. And also, we also have Telnet. So Telnet is a set of rules designed for connecting one system to another. Mostly, this is the initial stage of remote system connection or establishing remote connections with another network, or what I mean another client computer, wherein you can send command lines through in the internet from a remote desktop or laptop. Okay, Gopher is a collection of rules implemented for searching, retrieving, as well as displaying documents from isolated sites. So Gopher is somewhat like the FTP, but it's more on isolated cases naman. So moving forward, we will be digging deeper to the Internet Protocol. Okay, so when we say Internet Protocol, it's a set of rules that dictate how data should be delivered over the public network. When we say how data should be delivered, it refers to the transmission of or routing of such data. Okay, it often works in conjunction with the TCP, as I've mentioned a while ago, which divides traffic into packets for efficient transport through the network. Okay, so working hand in hand with TCP and IP, it gives way for us to divide data, reroute those data in various paths, which can be defined or can be what they call this determined by the Internet Protocol for it to reach the destination more quicker or more faster in depending on the distance, the number of IP addresses that or servers that it will be going through. Okay, so there. So again, so IP is subdivided into two, or mainly focuses on two aspects, which is routing and IP addressing. So for now, we will be focusing on routing protocols. Okay, so when we say IP routing, it's the field of routing methodologies of IP or Internet Protocol packets within and across an IP network. It involves not only protocols and technologies, but includes the policies of the worldwide organization and configuration of the Internet infrastructure. In each IP network node, IP routing involves the determination of a suitable path for a network packet from a source to its destination in an IP network. The process uses static configuration rules or dynamically obtained status information to select specific packet forwarding methods to direct traffic to the next available intermediate network node, one hop closer to the desired final destination. To sum up, so when we say IP routing, as I've said a while ago, it is the algorithm, the policy, or the set of rules that defines which path or which path, as I've said, path is the best way to reach the destination in the most suitable or most efficient way. Okay, it's somewhat like in our scenarios, no, sa real life now, we are going to drive into one destination, no. So one example, let's take for consideration of the Waze app, something like the IP routing. Okay, the Waze app gives us the capability to see the best best path to that destination, if there are traffics, if there are obstacles in the way. So it gives you an alternative ways to go to that destination. Same with IP routing. So that is somewhat comparison in real life. Okay. So in routing protocols, there is also what we call IP forwarding algorithms that take into account the size of each packet, the type of service specified in the header, as well as the characteristics of available links to other routers, such as link capacity, utilization rate, and maximum datagram size that is supported on that link. Okay, so IP forwarding algorithms focus on understanding what is being transported. Okay, so like packaging, diba? So IP forwarding algorithms, let's say for delivery, no? Syempre, iba yung delivery for our refrigerator, iba yung para sa mga small items. So this is the IP forwarding algorithms is concerned, no? So more on what is the best carrier, what is the best path, depending on the size of the data that it is trying to transport. Okay, that is for the IP forwarding algorithm. Okay, so it minimizes the cost when choosing the next hop. So there. For routing protocols, may be broadly distinguished by their realm of operation. In terms of network, interior gateway protocols are used for routing within autonomous system, while exterior gateway protocols route traffic between them. The former group is exemplified by Routing Information Protocol, or RIP, and open shortest path first, while exterior gateway protocol, the border gateway protocol are examples of the exterior type. So this is just to give us a brief or somewhat idea of different routing protocols that are used of the internet protocol. But we will not be digging deeper for this learning or this lesson. Okay, so now we will be focusing on IP addressing. Okay, in internet protocol, IP addressing is one of the primary or essential things in transporting data. So like in our real world delivery system, it is important to know the address of the source and the destination. No, it gives way for us to know what is the difference or the distinction of each node in a network. Now, since we are focusing in IPv4 and IPv6, so what we are experiencing now in the birth of IPv6 is what we call IPv4 address exhaustion. Okay, this is wherein the depletion of the pool of unallocated IPv4 addresses. So because the original internet architecture had fewer than 4.3 billion addresses available, depletion has been anticipated since the late 1980s. So there was a dramatic growth that is being experienced now. So having different technologies like mobile phones, smartphones, laptops, desktops, microprocessor that gave birth to Internet of Things, and other technologies that are being connected into the network is what we call a dramatic growth in the network. Okay, so this gave way to the depletion of one of the reasons for the development and deployment of its successor, which is IPv6. So every node in the Internet Network Protocol or Internet Protocol network, such as computer routers, network printers, is assigned of an IP address. Okay, so the existing Internet Protocol version 4 provides 2 raised to 32 or 4,294,967,296 addresses. However, large blocks of IPv4 addresses are reserved for special uses and are unavailable for public allocation. Okay, so the IPv4 addressing structure provides an insufficient number of publicly routable addresses to provide distinct address to every internet device or service. Okay, also although we have the what we call a MAC address, no, so it is a hard-coded hard-coded address to a specific node. The IPv4 is a different story. So this is more on the Internet Protocol routing, no? Okay, so the problem is now today is since we have millions or probably trillions of devices connected to the network, IPv4s or using the IPv4 making it somewhat unmanageable anymore compared to what was the initial stage of technology. Okay, so in addition, network addresses translation or NAT permits the internet service providers and enterprises to masquerade private network address space with only one publicly routable IPv4 address on the internet interface of main internet router. So this is the NAT only gives way for what we call this a workaround in the existing limitation of IPv4. Okay, so instead of every private network or private IP address is publicly available in the public network, so it is being masquerade or masked into one public internet or IP address. Okay, so that is the purpose of NAT. Now, let's talk about IPv4 versus IPv6. Okay, so let's be comparing IPv4 versus IPv6. Okay, so IPv4 is the fourth version. That's why it's called IPv4. Okay, it was first established in 1982 in SATNet and ARPANET in January 1983. Okay, so this is the first publicly available na internet protocol. While IPv6 is the soon-to-be what they call this succeeding internet protocol for IPv4. Okay, so it is the most recent one developed since there is an IPv4 address exhaustion. So it was first established in 1998 in the draft standard of IETF, the IATF, IETF. Okay, who subsequently ratified it as an internet standard on 14th of July 2017. Now, for a short comparison, no, so IPv4 was deployed in 1981 while IPv6 in 1999. Sir Josh, bakit hindi pa siya na-implement during that time? So mainly because of our existing network infrastructure in our ISPs. Okay, since IPv4 cannot be used to communicate with IPv6, or there is no such thing as backward compatibility, it's very costly for internet service providers to implement an infrastructure that would enable the communication between the two, and also having that such technologies that will enable both IPv4 and IPv6 running in the market. Okay, so just for comparison, mainly IPv4 and IPv6 differs in the address size. Okay, compared with IPv4, IPv4 only has around 4 billion more or less allocations, while for IPv6 it's 340 undecillion. So as you can see, after 340 there are other 36 digits that are available, or yung ganun kalaki yung addresses na available with IPv6, which is very in demand in our situation today, especially that everyone is now revolving in technologies, mobile phones, internet connecting things in the network. No, and automating things that are previously not happening. So that is the main purpose of an IPv6. Okay. Now we'll talk about types of servers in the networking protocol. So mainly we have the DNS server. When we say DNS or domain name system, it's maintained by a distributed database system which uses client-server model. So mainly, to make it short, DNS servers are separate servers that has directories of domains and IP addresses each domain has. Okay. While web servers refers to servers that are dedicated for transacting HTTP or distributing web servers. I mean web pages, okay? And a successor of it, of HTTP, is what we call HTTPS, as mentioned a while ago. Okay? For FTP servers, it is more on the file transfer. Okay? It's a dedicated server that acts as a file server where you can use FTP protocol to transfer to and from that server, and can be encrypted so that it can be FTPS or SSHFTP, okay, or SFTP. Okay. URL. So URL is a colloquial term as web address. Okay, this is a reference to a web resource and specifies its location on a computer network and a mechanism for retrieving it. Okay, as mentioned a while ago in DNS, so kanina hindi ko na masyado na-explain yung domain, but when you say domain, it is a URL representation or a masked version of an IP. So there. Let's talk about domain name system, okay? So domain name system, as mentioned a while ago, it's a hierarchical, decentralized naming system for computers. So there are certain servers that has a directory of URLs or domains that translate to an IP address. So this is used in our internet protocol for us to be more familiar or to easily access certain servers instead of memorizing IP addresses. Imagine na, lalo na kapag we are implementing IPv6, you have to memorize those lengthy addresses for just to connect to a specific server. So that is the purpose of a domain name system. Okay, so DNS. So function of DNS. So it's often used analogy to explain DNS. It serves as a phone book for the internet by translating human-friendly computer host names into IP addresses. So, like for example, when we have a URL, a domain name of www.example.com, it translates to the addresses 93.184.216.34 in IPv4, or its equivalent in IPv6. Okay, the DNS can be quickly and transparently updated, allowing services location on the network to change without affecting the end users who continue to use the same host name. So imagine na lang kung nag-down yung isang IP address, no, at ang IP address lang yung alam natin. Kung walang DNS, so most probably it would be chaotic in our existing networking infrastructure. Okay, it's a very great advantage that we have users to take advantage of this when they use meaningful URLs and email addresses without having to know how the computer actually locates those services. So that's one of the primary functions of the DNS. And an important and ubiquitous function of the DNS is its central role in distributed internet services such as cloud services and content delivery networks. When a user accesses a distributed internet service using a URL, the domain name of the URL is translated to an IP address of a server that is proximal to the user. Okay, so the key functionality of the DNS exploited here is that the different users can simultaneously receive different translations for the same domain name. A key point of divergence from the traditional phone book view of the DNS, this process of using the DNS to assign proximal servers to users is the key to providing faster and more reliable responses on the internet, and is widely used by most major internet services. To sum up lang, no, we have mentioned a while ago of the routing algorithms, right? So in the DNS setup, no, a DNS server also knows the quickest route to a specific node or specific server. So that gives way na even though na instead na you are accessing a server in China, magro-route ka pa into America back to China, a DNS server gives you the capability to detect na meron palang direct route to China. So something like that. So that is one of the functions also of a DNS. Now let's talk about domain and subdomains. So a domain name, as said a while ago, is an identification string that defines a realm of administrative autonomy, authority, or control within the internet. So domain names are used in various networking contexts and for application-specific naming and addressing purposes. So a domain name identifies the network domain, or it represents an internet protocol resource, such as a personal computer used to access the internet, a server computing hosting a website, or the website itself, or any other service communicated via the internet. Okay, that is the domain name. In a DNS hierarchy, a subdomain is also a domain that is part of the main domain. For example, if a domain offered an online store as part of a website, example.com, it might use the subdomain shop.example.com. Like for our case in PLMon, if I'm not mistaken, we have a portal, student portal, that is also linked to the domain of plmon.com. Okay, so something like that. So now we also have ports. Port is a communicating endpoint at the software level within an operating system. A port is a logical construct that identifies specific process or type of network service. Okay, a port is identified for each transport protocol and address combination by 16-bit unsigned number known as port number. Certain examples of ports are here. 20 for file transfer protocol, 21 for command FTP command control, 22 for SSH, 23 for telnet, 25 for SMTP. We have 53 for domain name system, 80 for HTTP, and so on and so forth. So to make the story short, as I said a while ago, different ports pertain to different services that are accessible in a specific web server or specific client. Okay, kasi in a specific computer, you can configure it as a DNS server. You can configure it also as a web server. You can also configure it as an Active Directory, which refers to specific ports that can be accessed through a specific IP. So that denotes the services that you want to use in a specific resource. So that's the main purpose of ports. So that concludes the lesson for today. So thank you and God bless.
Yun po. So,
Okay, so
hello. Ayun po. So kung meron po kayong mga gustong i-share or gustong i-clarify, pwede naman pong magtanong or mag-ask tayo din sa mga may specialization regarding networking.
okay, so prior to that, prior to that question, I just want to add on some additional inputs from, of course, related to the topic. So for communication fundamentals, so all communication methods have three elements in common. So the source or sender, the destination or receiver, and the channel or media. We have the rules or protocol given all methods or govern all methods by the communication. So of course, in protocols are necessary for effective communication include unidentified sender and receiver, common language and grammar, speed and timing of delivery, confirmation or acknowledgement requirements. For the protocol used in network communication, also define message encoding, message delivery options. By the way, okay, so I thought I was not done. Okay, again, some protocol used in network communications, as I mentioned, message encoding, message delivery options, formatting and encapsulations, message timing, and message size. When we say message encoding, encoding between hosts must be in appropriate format for the medium. Messages are first converted into bits by the sending host. And each bit is encoded into a pattern of sounds, light waves, or some electrical impulses depending on the network media. The destination host receives and decodes the signals in order to interpret the message. So when it comes to message formatting and encapsulation, there is an agreed format for letters and addressing letters, which is required for proper delivery. So putting the letter into the address envelope is called encapsulation. No, each computer message is encapsulated in a specific format called a frame before it is sent over the network. Because a frame acts like an envelope, providing destination address and source address. No? For the roles of message size, human breaks long messages into smaller parts of sentences. Long messages must also be broken into smaller pieces to travel across a network. No, each piece is sent in a separate frame. No, because each frame has its own addressing information, and a receiving host will reconstruct multiple frames into the original message. Now, how about the rules in message timing? We have an access method, right? Wherein the host on a network need to know when to begin sending messages and how to respond when collisions occur. We have the flow control, wherein a source and destination host use flow control to negotiate correct timing to avoid overwhelming the destination and ensure information is received. We have also a response timeout, no? Wherein the host on the network have rules that specify how long to wait for responses and what action to take if a response timeout occurs. So in message delivery options, we have one-to-one delivery, we have one-to-many delivery, and we have one-to-all delivery. So when we say one-to-one delivery, that is unicast message. When we say one-to-many delivery, that is multicast message. No? When we say one-to-all delivery, that is what we call broadcast message. Now, how about the protocol rules that govern communication? We have content layer, rules layer, and physical layer, right? So the protocol suites are implemented by host and networking devices in software, hardware, or both. Because the protocols are built in terms of layers, which is higher level service depending on the functionality defined by the protocols. No? As I mentioned, between the physical layer, the rules layer, we're in the conversation protocol suite, no? Use a common language, wait your turn, and signal when finished. That is the rules layer. Then, of course, the network protocols, no, the networking protocols define a common format and set of rules for exchanging messages between devices. And some common networking protocols are the HTTP, no, the hypertext transfer protocol, the transmission control protocol or the TCP, and of course our internet protocol. So, for example, I will send this a message across the network using an IPv4 header. So therefore, I can forward this message because I understand the IPv4 header. No? Then, of course, I can accept the message because I understand IPv4. This is the way or the format of structure of the communication pieces. Now, when it comes to network protocol. The protocol interaction per se, no? Communication between a web server and web client is an example of an interaction between several protocols. Again, we have a layer now, a layer, for example, application, transport, internet, and network access. So for application, we are using HTTP. No, for transport, we are using TCP. For internet, we are using IP. And for network access, we're using Ethernet. No? So, of course, when we say HTTP, it is an application protocol that governs the way a web server and a web client interact. No? But when we say TCP, that is transport protocol that manages the individual conversation. Well, the IP encapsulates the TCP segments into packets, assign addresses, and delivers to the destination host. In the Ethernet, allows communication over a data link and the physical transmission of data in a network media. Now, so a protocol suites and industry standard. Now, a protocol suite is a set of protocols that work together to provide comprehensive network or communication services, or may be specified by a standard organization or developed by a vendor. The TCP/IP protocol suit in is an open standards, no? That protocols are freely available and any vendor is able to implement these protocols on their hardware or their software. So for example, in the layer name, no, for TCP/IP, no, in application for TCP/IP, we have HTTP, DNS, DHCP, FTP. For the transport under TCP/IP, we have TCP and UDP. For the layer name internet, when it comes to TCP/IP, we have IPv4, I5, ICMP4, or B4 I mean, MPv6. No? For the ISO, no, for application, we have AXE, ROSE, TRC, SESE. No, for transport, we have TPO, TP1, TP2, TP3, TP4. For the layer internet, under ISO, we have CONP, we have CMNS, we have CLNP, we have CLNS. Then, for the Apple Talk, no, they are for application, they are using AFP. For the transport, they are using ATP, EAP, NBP, and RTMP. For the internet, they are using AARP. How about for the Nobel network? Under application layer, they're using NDS. Under transport, they are using SPX. For the internet, they are using IPX. Now, in the network access of this TCP/IP, ISO, Apple Talk, and Nobel network, the Ethernet, PPP, and the frame relay, ATM, and VLAN are the same with this layer. Now, as I mentioned, in development of TCP/IP, no, I think, no, during our freshman in BS program, no, our professor discussed about ARPANET. That was the predecessor to today's internet. It was founded no, by the U.S. Department of Defense for the use of universities and research laboratories. So we have, of course, the TCP/IP protocol suite, no? We have the application layer, the DNS, boot P, DHCP, no, for host config. For email, we have SMTP, we have POP or the POP and IMAP. For file transfer, we have FTP, TFTP, and for the web, we have HTTP. For the transport layer, we are using UDP and TCP alone. No? For the internet layer, we are using IP at saka NAT and IP support like ICMP. For routing protocols, we use OSPF and EIGRP. And for the network access layer, we are using ARP, PPP, Ethernet, and interface drivers. So, when we come to the TCP/IP communication process, when sending data from web server to a client, the encapsulation procedure would be as follows. No? The web server prepares the hypertext markup language page. Then the HTTP application layer protocol sends the data to the transport layer. Then the transport layer breaks the data into segments and identifies each. Then next, the IP source and destination address are added, creating an IP packet. Then the Ethernet information is then added, creating an IP packet. Then the Ethernet information is then added, creating the Ethernet frame or data link frame. No? So when receiving the data link frames from the web server, the client processes and removes each protocol header in the opposite order. No? Of course, first the Ethernet header is removed, then the IP header, then the transport layer header. Finally, the HTTP information is processed and sent to the client web server. So what are the available open standards? Because open standards encourage interoperability, competition, and innovation. The standard organizations are usually vendor neutral or neutral, no? Non-profit organizations established to develop and promote the concept of open standards. I think we are all familiar with IEEE, no? ICANN, ITU, TIA, IETF, no? And IANA, no? Of course. So, the internet standards, we have the Internet Society, no, ang ISOC. We have the Internet Architecture Board. We have the Internet Engineering Task Force, and so on. No? The benefits of using a layered model, no? It assisting in protocol design. Since protocols at its layer have defined functions. Actually, it is also fostering competitions because products from different vendors can work together, preventing technology changes in one layer from affecting other layers. And of course, it provides a common language to describe networking functions and capabilities. So I don't want to discuss the OSI reference model because you are all familiar with that. The layer number 7 is application, 6 presentation, 5 session, 4 transport, 3 network, 2 data link, and 1 is the physical. So for the message segmentation, no, for the data transfer in the network, no, large stream of data are divided into smaller, more manageable pieces to send over the network. So by sending smaller pieces, many different conversation can be interleaved to the network. It is what we call multiplexing. No, each piece must be labeled. No, if part of the message fails to make it to the destination, only the missing pieces need to be retransmitted. No? Now, the protocol data units, no, for the data encapsulation, no, as application data is passed down the protocol stack, information is added at each level, and this is known as encapsulation process. The form that the data takes at each layer is known as protocol data unit. So we have the data or the application layer, we have segment, the transport layer, we have packet, the network layer, we have frame, no, the data link layer, and we have bits for the physical layer of our protocol data units. So what will be the example of the encapsulations? So the encapsulation process works from top to bottom. No? Data is divided into segments, as I mentioned earlier. The TCP segment is encapsulated in the IP packet, and the IP packet is encapsulated in the Ethernet frame. No? How about the de-encapsulation? The de-encapsulation process used by receiving device to remove one or more the protocol header. So the data is encapsulated as it moves up the stack toward the end user applications. For the data access, no, of a network addresses, a network layer resource and destination addresses is responsible for delivering the IP packet from the original source to the final destination. So when we say source IP address, the IP address of the sending device, the original source of the packet. So the destination IP address is the IP address of the receiving device, the final destination of a packet. So for example, of course, the final destination is the web server, no? So assuming that in our web server is 172.161.199. And the layer 3 IP packet, of course, we have the source IP and the destination IP. Now we need to identify. So from original source to the source IP to the destination IP. Then for the packet, we have the IP packet, no, going directly to the final destinations. Now, data link addresses. The purpose of the data link address is to deliver the data link frame from one network interface to another network interface to another network interface on the same network. So as the IP packets travels from from source to destination, it is encapsulated in a new data link frame when it is forwarded by each router. No? So when it comes to the devices on the same network, the network layer addresses or IP addresses indicate the original source and the final destination. So the network portion, of course, the leftmost part of the address indicates which network the IP address is a member of. For the host portion, the remaining part of the address identifies a specific device on the network. The data link frame, which uses MAC addressing, no, is sent directly to the receiving device, because source MAC address of sending devices, and the destination MAC address of receiving devices. No? So for the devices on a remote network, so for example, you are using a remote network, sending to the network, remote network, the source and destination IP addresses represent hosts on different networks. Because the data link frame cannot be sent directly to the remote destination host. Therefore, the frame is sent to the default gateway, wherein it is nearest router interface. No? The router removes the receive layer 2 information and adds new data link information before forwarding out the exit interface. Okay? So when we say network protocols in communication, this will cover the rules facilitate communication. The role of protocols is standard organization in facilitating interoperability in network communication, and the devices on the LAN access resource in a small to medium-sized business network. So I think that's it for that topic.